Hello everyone, I am Professor Amit Solanki from SND College of Engineering and Research Center, Yola. Today we will discuss the next topic of the Unit 3, that is the Induction Motor Drive Part 1. The topic is that braking. In that we will discuss the different types of induction motor braking, right? Braking is generally three types: dynamic, plugging, and regenerative braking. As we already discussed in the second unit about the DC motor braking, the braking is same, but according to motor, it will be changed. There are some phenomena. So as you know that what is the meaning of braking, electrical braking, that means to stop the motion, to stop the motor. That is called the braking. The braking is the process of reducing the speed of an induction motor. In that, today we are discussing about the induction motor, so that we will discuss totally with respect to induction motor. And in braking, the motor works as a generator, developing a negative torque which opposes the motion of the motor, right? The main concept of braking is to develop the negative torque. Whenever, how, and where it is employed, okay. So the main objective of electrical braking is to generate the negative torque, right? And the braking of induction motor is mainly classified in three types. So there are, for example, induction lift. In that lift, it is also the good example of the electrical braking. We already seen many more examples in our day-to-day life. In that, where brakings are used. So basically, brakings are three types: regenerative braking, so next one is plugging or reverse voltage braking, and third one is that is the dynamic braking. So basically there are three types of braking: regenerative braking, plugging or reverse voltage braking, dynamic braking. In that induction motor drive, the dynamic braking is also classified in four types. One is AC dynamic braking, DC dynamic braking, self dynamic braking, and zero sequence braking. So one by one we will discuss. That is, today we will discuss first the regenerative braking. Okay. So what is the basic concept of regenerative braking? In that already we have discussed what is the phenomena of the regenerative braking in DC motor. So concept of every braking is same for any motor, but change is that it will depends on the types of motor, right? Approximately concept is same for all our things, and it is change for the parameters according to the motor behavior. So in that, let us start the regenerative braking for the induction motor drive. Okay. As you know that the main concept of braking is to develop the negative torque. So in different braking, we have used different concept, process, control scheme to how to generate the negative torque. In that regenerative braking, the input power of the induction motor drive is given by the formula. So this is the formula for the input power in that induction motor, that is the P input power. This is equals to 3 into VIS cos pi s. Okay. So this is the basic formula for the input power of the induction motor drive. In that we can see here where phi of S is the phase angle between stator phase voltage and the stator phase current. Right? This is the phase angle. So for motoring operation, the phase angle is always less than 90 degrees. You should have to always remember that for motoring operation, the phase angle is always less than 90 degrees. And if the rotor speed becomes greater than synchronous speed, then the relative speed between the rotor conductor and air gap rotating field will be reversed. The main point is that for regenerative braking, how to create the regenerative braking and how to develop the regenerative braking in induction motor drive. In induction motor drive, so behind that, the basic fundamental concept of this braking is that so the rotor speed becomes greater than the synchronous speed, and then the relative speed between the rotor conductor and air gap rotating field. It will reverse the speed, and in that case, it will work as a generator, and we will develop the negative torque. So let us understanding in the next slide how it is developed. So this reverse the rotor induced EMF. Okay, if field is reversed, then it will what will we do? It reverse the rotor induced EMF, also the rotor current and component of stator current, which balance the rotor ampere turns. Okay, and when phi s, that means phase angle, is greater than 90 degree, then the power flow to reverse and gives the regenerative braking. So these are the all about the concept of the regenerative braking. What we do, we can do the phase angle is greater than 90 degree. The point is that, as we already discussed, if phase angle is less than 90 degree, then what will happen? It will work as a motor. And in that case, if phase angle is greater than 90 degrees, then it will work as a braking. In that case, we are using as a regenerative braking. Okay. The magnetizing current produces the air gap flux. The nature of the speed torque curve is shown in the next slide. You can see here how the speed torque curve is plotted. And when the supply frequency is peaked, the regenerative braking is possible only for speeds greater than the synchronous speed. This is the main limitations, or we can say that the specification of the regenerative braking of the induction motor drive. In that, when the supply frequency is fixed, the general braking is possible only for a speed greater than synchronous speed. With the variable frequency speed, it cannot be obtained for a speed below synchronous speed. Okay. So in that figure, in that graph, you can see here the nature for the speed torque, the relation between the regenerative braking of the induction motor drive. So in that, you can see here the basic concept characteristic for the regenerative braking. In that, this portion is known as the motoring operations. Graph is plotted between speed and torque. In that, you can see here. In that, from right side will be the regenerative braking. Okay, how to braking is applied. So these are the all about the concept of the regenerative braking of the induction motor drive. Thank you so much for watching this video.